Hello, everyone. I'm Ilana Koegelenberg. For those of you who don't know me, I'm shecco's Market Development Manager. And welcome to our Utilities and Incentive panel. I'm joined today by three top experts who will be sharing more information on incentive and programs available to help accelerate the uptake of natural refrigerants and climate-friendly technologies, all amongst other things. And we'll go through the presentations and have a Q&A at the end, so feel free to ask your questions. But I mean, on that note, on the housekeeping, when you look at the right of the presentation screen, you'll see there should be three tabs like there. So if you want to ask a question, please ask it in the one that says questions. You can feel free to chat as you want, but we might not get the question if you put it there. And then you'll also see some polls on on that right tab. So please have a look. I'll remind you about that later after the first presentation. But yeah, there's also a cool function where you can vote on the question. So if you agree with the question, or then the ones with the most votes obviously have a higher chance of getting answered. So that's something to keep in mind. But yeah, I mean, I'm sure you've heard all of these things before, so I'm not going to dwell too long on that. Let me introduce our first speaker, Morgan Smith. Welcome. She's the Manager of Programs and Operations at the North American Sustainable Refrigeration Council. Quite an acronym. She has multiple impressive degrees and a background in sustainability and communications, and has a particular interest in aligning sustainable behaviors with the goals of individuals and businesses. I'm not going to read out the whole thing, but if you click on any of the presenters' face, little icon, then you'll also see their full bios. So Morgan, over to you to present more on aggregating incentives for natural refrigerants. Thank you.
Thank you. All right, let me just pull up my slides here.
See your background. Can you see those? We see your desktop background still. So where's the hardest spot? Oh, there you go. You go.
There we go. Mm-hmm. All right. Well, good morning or afternoon, everybody, depending on where you're located. My name is Morgan Smith. I'm the Manager of Programs and Operations at the North American Sustainable Refrigeration Council. And today I'm going to be discussing a program we developed to aggregate financial incentives for natural refrigerant projects. Before I dive into that, just a quick overview of who we are. NASRC is a 501c3 nonprofit. We work in partnership with the supermarket industry to remove the barriers to natural refrigerant adoption in supermarkets. Our initiatives focus on achieving cost parity, filling data gaps, and ensuring that the service workforce is trained and qualified to work on natural refrigerant systems. We do all of this together with our network of 130 industry stakeholders, including manufacturers, contractors, engineering and design firms, consultants, utilities, and also retailers who represent over 24,000 supermarket locations in North America. So as we've heard in other sessions throughout this conference, supermarkets around the world are facing increasing regulatory pressures. So from a US perspective, at the international level, the Kigali Amendment to the Montreal Protocol established a global phase down of HFC refrigerants and has been ratified by, I believe it's 105 parties now. But the U.S. has not yet ratified it. But in the U.S., the general consensus is that the writing's on the wall, and it's more of a when rather than an if. Also, the Paris Climate Agreement, which included commitments to phase down short-lived climate pollutants, including HFCs, is another thing to keep in mind here. At the federal level, there's been an absence of certainty around what regulations are going to do in the U.S., but there are a number of regulatory pathways in addition to the international pathways that could impact supermarkets. So the Clean Air Act, EPA SNAP program, American Innovation and Manufacturing Act. And then really in the US, we've seen the majority of the activity at the state level through the US Climate Alliance, which was formed to uphold the goals of the Paris Climate Agreement and is composed of 24 states, 16 of which have made commitments to regulate HFCs or have actually adopted HFC regulations. California, as I'm sure many of you are aware, is sort of ahead of the other 15 states and has proposed more stringent regulations than any other state. All of this together is driving the transition to low GWP and natural refrigerants, which represents a significant cost for supermarkets. So we see this great opportunity, and we've heard from our retailer members that there's a need for funding support that can alleviate the burdens associated with natural refrigerants and help accelerate the transition to natural refrigerants. And that's what really led us to pilot this concept. So we launched an aggregated incentives program pilot earlier this year. You can see on the left side of my screen here, if there's not a lag, that under business as usual, if a retailer needed funding support, they would have to go after each source individually, and that would really be a complex process, likely resulting in less money. But on the right, under the aggregated incentives program, the idea is that a retailer goes directly through us, and we go after multiple sources of funding support for each natural refrigerant project. And ultimately, the goal here was to leverage the different funding sources that exist for natural refrigerants, compile them together, and maximize the amount of funding support we could get for each project, and most importantly, really streamline the process for retailers and ultimately demonstrate the need for continued funding support. I do want to highlight that we selected California for this pilot because there was this unique combination of a state funding program, the F-gas Reduction Incentive Program, or the FRIP program, combined with these stringent regulations that I mentioned a little bit earlier here, which are really driving the transition to lower GWP refrigerants. So that program was really the cornerstone of this pilot, and we actually just submitted those applications earlier this month. But there were other funding sources involved as well, such as utility incentives for energy savings, pilot funding for M&V lending, and then also funding for environmental benefits, such as grants and carbon financing. So though we don't have a complete set of results to share with everybody today because we just submitted applications, I did want to share some preliminary results with everybody. So we received 29 project applications in total. The majority of the systems were CO2 transcritical. The next largest was this sort of hybrid CO2 design, and that was followed by an R290 micro-distributed system. Not surprisingly, the majority of the projects were new stores, but we did have a few existing store projects in there. And there was also a good spread in terms of location across the state and the different types of retailers that applied. There are a few other exciting outcomes that came out of this pilot that I'd like to highlight. The first is the CarbFRIP M&V study, which we've developed in partnership with CARB and SDE. It's in development now. And the idea is that the study will compare the energy performance of the different natural refrigerant system designs that are selected to go through the CarbFRIP program. And one of the things that's really exciting about this is that the study would result in really high quality, highly trusted utility grade performance data for the industry. And so this is a great way to kind of tie together the incentives with the need for this energy performance. The next is our natural refrigerant technology library. And so to try to drum up some excitement around these and project ideas around the AIP pilot right before we launched, we hosted a live webinar series that consisted of 19 presentations showcasing the latest natural refrigerant technologies. And really, like I said, the idea was to kind of inspire projects for this program, but it's turned out to be this terrific resource outside of the program. So kind of another exciting spinoff from incentives. And then finally, perhaps most exciting and most relevant to this conversation today is carbon financing, which is sort of a spinoff of the AIP pilot. And the idea here is to create a market for buyers and sellers of carbon offset credits from the installation of natural refrigerant technologies. So there's already a protocol that exists to quantify these credits, but what's been lacking is a market to make these transactions happen. And so the idea is if we can make this, create this market, then retailers could also get funding support from the sale of these offset credits. So we've identified a buyer who wants a package of projects And what's really exciting is that the AIP pilot gave us basically the package to work with and to compile these projects together to really make these carbon offset credits add up as much as possible in a very compelling package. The season for the carbon offset credits is coming up in Q1 2021, roughly. So more to come on this, but this could end up being even more impactful than the AIP pilot because this source of funding is scalable across all states. In addition to the carbon financing, we see a big opportunity to scale utility incentives in the US. So I'm sure many of you on the phone are familiar with TUI, so I'll keep this brief, but TUI is the total equivalent warming impact. It's the sum of the direct emissions from the refrigerant and the indirect emissions from energy. And right now, most utilities are restricted because they can only incentivize the indirect emissions from the energy savings. But we're starting to see this change across a number of states where there's this broader conversation around decarbonization goals. And this is really opening up a unique opportunity to influence energy policy at a higher level. And specifically, what I mean by that is what needs to happen is for energy policy to incorporate GWP and refrigerants and essentially take the whole TUI calculation into account. So we're really aiming for energy efficiency and natural refrigerants. And what this would do is the energy policy influences the utility goals, which ultimately sets the, or it creates the metrics that utilities are able to incentivize. And so the goal here is that we could potentially help create this model where utilities would be in a position to incentivize natural refrigerants. And we see the U.S. Climate Alliance states as a great place to start because these states are already engaging in the HFC conversation. But ultimately, this really could be scalable across the whole U.S. because there are utilities everywhere. And because if we can create a replicable model, this is something that could be adopted in multiple locations. So to summarize, regulations at all levels are driving the adoption of low GWP and natural refrigerants, which is really reflecting an increased cost for retailers. By putting together multiple sources of funding or aggregating these funding support, we can sort of alleviate that burden and help to accelerate the transition to natural refrigerants. And then finally, aligning TUI goals, or what I mean by that is aligning energy efficiency and low GWP goals, could open up the opportunity for new funding sources. And I just included my email at the bottom of this slide in case anybody wants to follow up after this. But with that, I just want to thank Atmosphere America for the opportunity to share a little bit about this pilot with you all. And I will turn it over to Ammi.
Well, thanks so much. We get back. Thanks, Morgan. That's actually very encouraging to hear because we always find that policy and incentives are definitely one of the key drivers for the uptake of natural refrigerants. So it's good that there's been some progress. We'll take all the questions at the end, so don't go too far, but just a reminder to everyone again as well to please submit your questions on the right. But before I go over to Ammi, I want to, let's look at the first poll just to make sure everyone's still awake. This afternoon slump can happen. So the first question is you'll see that on the right next after chat questions, you should have polls. And it's what is your preferred refrigerant for the use in industrial refrigeration applications? Seeing as we were just going to talk now about another project. So you've got all your CO2, ammonia, hydrocarbons, HFC, and HFOs. So I'll read some of the answers at the end because I'm not sure how many of you voted. So far, we've got 23 votes, 70% of which are for ammonia. I'm not surprised. And then 26 for CO2 as the runner-up. So yeah, keep on voting. There's still time. Maybe stop share. And then let me introduce our next speaker. I'm very excited to be joined by, I'm sorry if I'm going to mess this up, but everyone always messes up my name as well, by Ammi Amarnath from the senior, he's a senior technical executive in the Electrification and Customer Solutions Research area of the Electric Power Research Institute. It's quite a mouthful. Ammi leads a team of engineers and scientists in the research and development, deployment, and market transformation of energy efficiency and demand responsive technologies, which is really exciting. And he's going to be presenting on ultra-low charge ammonia chillers for energy efficiency in industrial applications. So, Ammi, over to you.
Thank you, Ilana, and good morning. I'm saying good morning because I'm in the West Coast. I live in the San Francisco Bay Area. But good morning, good afternoon, good evening. This is a worldwide conference, so wherever you're calling from or wherever you're logged on from, my greetings from the West Coast of the United States. Once again, I would like to thank you, Ilana. I'd like to thank you, Franco. I'd like to thank Mark Cesaro and the entire group at Shecco for giving me this opportunity to talk a little bit about actually today I'm going to talk about a very specific project, and I'm going to share some of the results that we have received on that particular project. Ilana, I don't know if you did the polling just before.
Yeah.
Just to queue up my presentation or whatever, but yes, I am going to talk about ammonia. So
that's very well timed then.
Yeah, and actually, this is a good segue to Morgan Smith's presentation. So I'm going to do my presentation. Let me see if I can get this right. How does it?
It should just give it a second, but I think.
Yeah, how does it look now?
Perfect.
All right,
go ahead.
Again, I have to do another apology here. That is, my company does not allow, for whatever reasons, Zoom to be used, for us to be able to download the Zoom app and so on and so forth. So I'm sharing this from my browser, and I hope all of you can see this. And I'm going to push one slide up. Okay, and Ilana, is it moving okay?
Everything looks perfect. We'll let you know if there's a problem. All yours. Go for it.
Thank you.
Thanks, Ammi.
Hey, this has been a great conference. Again, I know I seem to be starting off with so many apologies, and another apology is that I have not been able to, unlike what Morgan just talked about, that she listened to the other presentations in this conference. I have not been able to do that. Primarily because if people are aware of EPRI, Electric Power Research Institute, this entire week we have a large conference, again online, a large conference on electrification. Started on Monday and ends on Friday. So it's all about electrification. So that's one. And then there are 3 or 4 other conferences happening at the same time. I think it's a very busy time of the year. But anyway, today what I'm going to do is I'm going to talk about a particular project. Again, this is related to ammonia chillers, but the nuance here is the ultra low charge ammonia, how to use very, very low charge ammonia chillers for energy efficiency applications in industrial setting. So I'm going to talk about that. But before, let me kind of start about, this thing. I just want to start with EPRI, who we are, what's the research motivation on this project, who are our partners, what's happening today and what are the results as we have seen it. It's an ongoing project, by the way. And I'd like to acknowledge some of my colleagues who have worked with me on this very specific project. So let me talk about EPRI. And I think, I want to kind of, cue into what Morgan just said about incentives and specifically utility incentives. I don't have any slides on that, but I think I should, given Ilana, what you said that this session is on utilities and incentives, I think I should talk a little bit about that. Okay, but initially, let me talk about EPRI, who EPRI is. EPRI is an independent organization. We are a scientific organization, probably perhaps the largest in the entire world, focusing on, what I show here, reliability, efficiency, affordability, health, and the environment, all to do with electricity, all to do with electricity and electrons. We're a nonprofit organization. The unique business model we have is we're a collaborative group. We bring together, greatest scientists from around the world and work together to make, to move the technology forward in this entire electricity space. I didn't mention electricity in the write-up, but the company's name is Electric Power Research Institute. So our focus is entirely on electric power. So really, our role is, to take technologies from, think of it as, technologies get commercialized and get applied by the utilities. And I want to talk about that a little bit more, get applied by the utilities. And our role is to kind of push these technologies towards those applications. Okay, so let me just sort of pause here for a second and talk about utility incentives and how they happen and so on and so forth. Okay, I'm sure many of the folks here on in this conferences are aware of how utilities put together incentive programs. Morgan talked about new incentive programs for natural refrigerants and so on and so forth, right? So utilities put together incentive programs in order to give incentives to very specific technologies so that it can be broadly applied and can provide value to the entire community that they serve. Again, that's very important, the entire community that they serve. So there are many tests that they do, to make sure, does these technologies have energy efficiency benefits? One test I'm going to talk about, I'm going to say, is what is called as a total resource cost, or what are the resources that are being put in place and what is the benefit that they get out of this stuff. And if this TRC goes over 1.0, then it can be put together for a program. In other words, the utilities give these work papers, so-called work papers, to the Public Utility Commission, and the Public Utility Commission thereby approves them. And once they're approved, then this goes into the utility incentive program. Okay. One part of this, test, total resource costs, ratepayer impact measures, and many other, metrics by which they look at these incentives. One of the most important aspects of these incentives is, for energy efficiency, I'm talking about, is the technology efficient? Is the new technology more efficient than the existing or the baseline technology, and how much more efficient it is? Okay, and that's exactly what I'm going to talk about. Is EPRI is a technical organization that does work from grounds up to figure out exactly what the energy efficiency aspects of particular new technologies are, and we share that with our member utilities. Our member utilities use that information in their work papers and put that forth to the Public Utility Commissions, who then approve a new incentive program. So it's very much related to the incentives, which is the session. So having talked so much about incentives, I'm going to skip a couple of slides because Morgan already covered it. That the motivation for our research and the motivation for, I guess, what's happening in this conference is all about reduction of greenhouse gas. It's all about decarbonization. So so the United States, the same chart, I guess, Morgan, that you showed, that I show here, which is reduction. States have formed alliances to reduce greenhouse gas emissions. So that's kind of the goal in which we worked on this particular low charge ammonia chiller. So what is happening in industrial processes today? Many process industries use chillers. Chillers are a major component of industrial processes. Okay, these chillers use refrigerants, usually that are synthetic, HFCs or hydrofluorocarbons, and they have high global warming potential. Morgan mentioned that. And how can we reduce the GWP of these? We can use them by using alternate refrigerants, like the poll showed, ammonia as being one of the refrigerants. But ammonia has got certain issues. What are the issues? Obviously toxicity, and there's distinct odor. And in the companies that use large amounts of ammonia, which is, usually ammonia required is about 20 to 30 pounds per ton of refrigeration. Okay, so by using large amounts of refrigerant, if you have like 1,000 tons or whatever, you use you get the idea. You use a lot of ammonia. Okay, for which the companies need to maintain OSHA paperwork, and need to maintain make sure that the ammonia that's used is safe and so on and so forth. Needs safety goals. New technologies are coming into the marketplace that use ultra low charge ammonia, and that is something in the between 1 to 3 pounds per ton of refrigeration. We are already talking about more than an order of magnitude reduction in the amount of ammonia that is used. But the big question is, are these new technologies more efficient than the baseline or existing technologies? Only if they're efficient. Remember, this session is about utility incentives. Only if they're efficient, then we can put them into utility incentive programs. Okay. I'm looking at my time, and I just want to be sure that I run through this quickly. So we have a current research project ongoing, and we are trying to address the energy efficiency potential of such low charge ammonia chillers. The project is mainly funded by the California Energy Commission, which is the overarching commission here in California. on everything related to energy. We are also co-funding this project. We have a very good technology provider, that's Maekawa. Maekawa is a company headquartered in Japan. However, they have operations here in the United States. So they have provided us with this ultra low charge ammonia chiller. The site where we are testing this system is a company called Takara. If you're from Japan, you'll recognize this very easily. Takara is probably one of the largest companies in the world that makes sake. Sake is a rice-based alcoholic beverage. Okay, so Takara makes sake, and this is one of the largest plants in the Americas. It's located in Berkeley, California, where sake is being processed, sake is being packaged and sold. Our research collaborator on this is Electricité de France, EDF's offices here in California. They bring a lot of value in terms of understanding technology and market potential and things of that nature. They're supporting us on this project. Okay, I mentioned this already. The demonstration site is at Takara Sake in Berkeley. What we are testing is a low charge ammonia chiller, brand name called Aura by Maekawa. This low charge ammonia chiller uses 1.5 pounds of ammonia per ton of refrigeration. It is air cooled also. It's not water cooled, but it's air cooled. Okay, it's rated at 50 tons, and it's used to cool, the sake fermentation tanks that you see in the background on the right hand side on the top photograph. Okay, so fermentation tanks are where sake is fermented and fermentation is an exothermic process, produces heat, and the heat needs to be removed, and it's removed by chilled water, and you need a chiller to chill that water. Essentially, that's what it's used for. Okay, and the baseline equipment that we are using is an HFC chiller. It's a Refrigerant 507A. That's also running in the process. They're running side by side. Initially the HFC chiller was used for this fermentation process, but since we put this brand new chiller in place, they've taken this other chiller and used it to use in the so-called liquefaction tank, which is another part of the process. However, we are testing these two things at an identical condition that I'll explain in the next couple of slides. Okay, what makes low charge ammonia chiller? The reason we're able to use this ultra low charge is because of two things. One is microchannel heat exchangers, which is in the latest and the greatest in heat transfer technology that has been developed, not only by Maekawa, but many other companies. Many of them are probably on this conference call. So this is one thing. And the second thing is the semi-hermetic compressor, using aluminum windings instead of copper windings. It's practically leak-free. So ammonia doesn't leak, so you can use very low amounts of ammonia. Okay, so I said earlier on what we are doing, and this diagram shows it in detail, but I don't want to talk too much about it. To say that we are using the ammonia chiller, and then we are comparing against HFC chiller, side by side, operating under the same conditions, and we are able to figure out which one is more efficient. Okay, so what we have found so far, the project is ongoing. Let me just remind you. Project is still ongoing. What we have found so far is fantastic news. Okay, the ambient temperature is low. Berkeley is near San Francisco. Has got it's very mild climatic conditions. So let's say the operating conditions of 70 to 80% capacity and ambient temperature around 70 degrees Fahrenheit. The chilled water supply, the chiller is chilling the water, like I said, chilling it up to 43 to 46 degrees F. What we have found is that this chiller is 40% more efficient than the baseline chiller. So there we have the number that we can provide to our member utilities to say, hey, how can you put incentive programs on that? So this is a very important information that we have gotten so far. Side benefit on this, since it's air cooled, okay, it's comparing against a water cooled, we are saving water. Okay, which in California, drought stricken, we have not had 1 millimeter of rain this year so far, or this season. The season starts in July. We have not had any rain so far, so we are a drought born state, and we are saving water, which is important. Okay, so we are saving both water and energy, and this is an air cooled chiller. So conventional sense tells us the water cooling is more efficient, but because of the mild climatic conditions, air cooled chiller is equally or even better. Okay, so I mentioned all the savings, the between the two this thing, and this results is going to be provided to the California Energy Commission and the utilities who are participating with us, especially the utilities in California. Finally, I want to acknowledge my colleagues Sarah Biani, Aaron Tam, and Colin Lee, who are working very closely with me in completing this, and a full report, public report available through the California Energy Commission website will be made available hopefully in the early part of 2021. With that, I thank you for listening to me. And I hope I didn't go too much over time. Thank you.
No, it's okay. Thanks, Ammi. You can stop sharing your screen now.
Okay, I'll do that.
Yeah, that's very exciting. I look forward to that report. I'm sure a lot of us do. And also, I mean, the fact that it's like you said, it's an air-cooled chiller comparing to a water-cooled chiller, and it's still 40% more efficient. That's quite a good result. So I'm excited to see.
Amazing? I mean, the utilities are asking us already, how can we put this into incentive program? What do you have? And we are saying, hey, the research is still ongoing. Wait for a few more months, and then we'll give them to you.
Well, that's the exciting part, when you've got the numbers and they speak for themselves. So I'm happy. Well, thank you. We'll take a bit more questions at the end. Before I go over to our last speaker, Ali, you guys are familiar with it now, so let's check out the other poll as well. The second poll is, it's exactly what the session is about. Would increasing the availability of incentives for low GWP alternatives drive the wider adoption of natural refrigerants in the Americas? So this one's a quite straightforward yes or no. So far we've got 32 votes, 88% of which say yes. So not surprising. That's probably just once again testament to why this session is so important. On that note, ammonia is still the front runner on the other poll, though CO2 is taking a bit more of the space now. It's on 58% still ammonia though. But yes, just another reminder again, the questions are on the right next to the polls really. So on that note, let me hand over to our final speaker, Ali White, who is the VEIC. I hope you'll tell us what that stands for. Energy Consultant for Efficiency Vermont's commercial and industrial customers. And through this energy efficiency utility, she develops innovative energy saving solutions tailored to their business models and strategies, amongst many other things. And yeah, she'll be sharing a bit more about what Efficiency Vermont does and the opportunity for incentives. So thanks, Ali. The floor is all yours.
Yeah, thank you so much. Let's see if I can successfully share my screen.
It's always the hardest part.
Yeah.
No, you're
looks
good.
like it worked.
Perfect.
Great. Okay, so yes, thank you everyone first of all, thank you for being here. I do appreciate how busy we all are these days and the stress of the state of the world. So I just really like to say thank you, and I appreciate you taking time out of your day to attend this session, and I'm looking forward to some great discussions. So my name is Ali White. I'm an energy consultant at VEIC, specializing in commercial and industrial refrigeration systems. I'm part of a broader 15-person team that focuses specifically on refrigeration and reducing the energy consumption of refrigeration systems, as well as transitioning to low GWP solutions. Just a bit about what VEIC does. We are a mission-driven nonprofit organization that's focused on generating sustainable energy solutions to mitigate climate change. Greenhouse gas reduction is our true north, and so as you can imagine, refrigeration and refrigerant emissions tie in perfectly. And beyond refrigeration, our non-biased third-party expertise includes energy efficiency across all sectors, building decarbonization, transportation electrification, and a focus on developing new approaches for a clean and flexible grid. And so within our commitment to greenhouse gas emissions, we appreciate the dual focus on both the direct and indirect emissions associated with refrigeration systems. And our roots are really in developing energy efficiency utility programs. And so as much as we are passionate about transitioning to natural refrigerant systems for the carbon savings, we also are very, for the direct carbon savings associated with the refrigerant itself, we're also equally as passionate about reducing the energy consumption of refrigeration systems. As we're all aware, refrigeration makes up a huge percentage of global energy consumption, and that's only increasing as more economies gain broader access to refrigeration. And we also focus a lot on technical energy savings calculations, but also removing economic, technical, and supply chain barriers to natural refrigerant adoption. As I mentioned, we really have our roots in establishing energy efficiency utility programs. And so Efficiency Vermont is one of those programs, and I'll talk more about our work with natural refrigerants. And we also operate the District of Columbia Sustainable Energy Utility in DC, and Efficiency Smart, which is based in Ohio. In addition to our EEU services, we also provide direct-to-business consulting services and work frequently with governmental organizations to implement different efficiency programs and greenhouse gas reduction programs. So we have really focused in on refrigeration because of its outsized impact, and really that was spurred by the great work that's been done by the IPCC and Project Drawdown, as I'm sure we're all familiar, just identifying refrigerant management and transition to low GWP refrigerants as one of the most important, if not the most important things we can be doing to mitigate climate change. And so we've used our roots in utility energy efficiency programs to help retailers and contractors apply for utility rebates specifically for natural refrigerant systems. And in addition to that, we also develop refrigeration energy efficiency programs, help end users, manufacturers, contractors, really anyone navigate state-by-state utility programs and HFC phase-down regulations. And also we have an emerging technologies division that evaluates through market research and through pilot projects what technologies are coming down the pipe, and certainly there are plenty as it pertains to natural refrigerant systems. So I didn't include any slides about greenhouse gas reduction incentive programs because I knew that Morgan would do a great job presenting on those, and she did. And so while states are figuring out how to adapt a program like CARB's F-gas incentive program to meet their specific needs and goals, and we're all eagerly waiting for that to happen. But in the meantime, I wanted to highlight the utility efficiency program landscape, and Morgan and Ammi both touched on this, but there are plenty of opportunities in certain utilities and in certain climates to access significant incentive program funding through utility energy efficiency programs. Any utility program that offers custom energy efficiency rebates like National Grid, Eversource, Con Edison is worth reaching out to when designing a new store or a remodel. And in certain climates, CO2 specifically, but ammonia as well, can result in significant energy savings thanks to floating head pressure controls and other efficiency measures that aren't technology specific, but are very favorable for certain refrigerants. Some utilities also have emerging technologies divisions as well. And so this is far from an exhaustive list, but just part of what we've seen and had success with. We have been able to calculate utility approved energy savings for micro DS or micro distributed R290 systems, including the energy penalty of the water loop pumping system. We've still been able to find significant energy savings over certain traditional rack systems. CO2 to glycol chiller systems, although certainly that option, you do have an energy penalty with the glycol pumping, but certainly if you were able to take advantage of a program like California's, where they have the energy and non-energy greenhouse gas incentive dollars, that would be a perfect application for that type of system. Transcritical CO2 booster systems, we're all familiar that those perform fairly well in cold climates to begin with, and then there are a lot of exciting new components that are being added in. And then industrial ammonia systems, traditionally ammonia has been around for a long time, and it is a very efficient refrigerant, and it's also an amazing natural refrigerant. So that's great. And we've actually evaluated for some of our larger industrial customers that we've worked with are looking to move away from ammonia due to all of the EPA regulations and the safety protocols and expenses that are included in maintaining those systems. And so we've evaluated in certain Northeast climates that CO2 transcritical systems can still achieve energy savings over ammonia systems. And that's been really helpful in addition to all of the non-energy benefits associated with CO2 over ammonia. It's been really interesting and has helped move some of those systems over to CO2. You can also stack energy efficiency measures when you're engaging with utility energy efficiency programs. So, CO2 has a huge opportunity in certain climates to achieve floating head and suction pressure control savings. The electronic expansion valves that are baked into every CO2 system and the nature of CO2's high operating pressures allow you to float the head pressure incredibly low during colder ambient temperatures without any negative impact on compressors or oil return. So that's super exciting. Adiabatic gas coolers, again, can be tied in conjunction with CO2 systems to float that head pressure and control to wet bulb temperatures year round, which in certain climates can lead to significant energy savings over even floating according to dry bulb temperatures. CO2 is great for heat reclaim as well if you're working with the utility that offers rebates both for electricity and thermal energy reduction. Hot gas defrost and efficient refrigerated cases. Again, the electronic expansion valves inherently included with case controllers result in energy savings that can be calculated. And then coming down the pike, what we're really excited about is CO2 condensing units. We've seen some manufacturers breaking into the US market and claiming energy savings over a 404A condensing unit. And so we're excited to do some pilot projects and verify those energy savings. There's also some manufacturers making air-cooled R290 cases that still have good energy savings and don't include that water loop pumping penalty. And as I mentioned, CO2 add-ins like ejectors, parallel compression, mechanical subcooling, those all hold a lot of opportunity. And while they're designed for warmer ambient climates, they can achieve energy savings in any climate. Even in Vermont, our summers are getting increasingly hot and increasingly humid, and it's not uncommon to see condensing temperatures, at 110 degrees. Something else I wanted to highlight that is, it's geared toward utilities and manufacturers and contractors, and really anyone who's trying to engage the supply chain when it comes to natural refrigerant systems. Obviously, bringing stakeholders to the table is just so critical, and there's been plenty of great presentations from contractors and end users, and examples of great partnerships that have made projects successful. And I kind of just wanted to drive that home. And so a few things that Efficiency Vermont's done, we partnered with Emerson to host a CO2 training for contractors that was hosted at a distributor's location. We designed a first of its kind refrigerant leak repair program where contractors are proactively searching for and fixing refrigerant leaks. And we surveyed them extensively to design that project and really make them the drivers of that program to good success. We facilitated R290 certification courses through RSES. And just to talk quickly about Efficiency Vermont, we are very passionate about refrigerant management, transitioning to natural refrigerants. And so, and we also have a good bit of flexibility in the projects we can support through our custom programs. So I'm not saying that this is achievable anywhere in the country currently, but I wanted to present Efficiency Vermont as an example of the role utility programs can play in transitioning to natural refrigerants. So in 2020, we really doubled down on our support, and we completed 5 large natural refrigerant system projects that went into the state, all as new construction opportunities. The average savings we were able to claim was 410 megawatt hours annually over a baseline system. Sometimes that was a baseline CO2 system that did not have any added efficiency components. Sometimes it was a traditional 404A system. The average incentive that we were able to bring forth was $60,000, resulting in a payback of the incremental cost associated with the natural refrigerant system being between 3 to 5 years, which is within an acceptable rate for most organizations. I've seen great results with adiabatic gas cooling, and we've 2 of the projects, they've been able to avoid going into supercritical mode at all in the summer using adiabatic gas cooling. And that is still impressive in Vermont because, as I mentioned, it's very humid. And a lot of those energy efficiency measures are baked into the design of these systems, and that makes calculating the energy savings and getting utility support even easier. Great, thank you very much.
Thanks, Ali. I think all I can really say is keep up the good work. That's encouraging to hear. I think we'll get everyone on the panel back now and then take some questions. Thank you everyone for staying with us. Well, before I do that, I've got a couple of questions here, so I hope you're all ready. Feel free to submit more, but let's just look at how the polls are doing. Yeah, ammonia is still the preferred refrigerant. Ammi, you'll be happy, 63%, CO2 at 32, yeah. Still, yeah, it's a classic, can't go wrong. And then yes, 90% of people have voted, 42 votes now say that if there were more incentives, it would actually drive a wide adoption of natural refrigerants. So that really just drives that point home again. So we've got a lot of questions specifically, I mean, especially about that chiller, your case study. Mike Lloyd wants to know if the R507A chiller was a new unit or not, if it was the existing unit.
Yeah, good question. Very good question.
We knew it was coming.
No, it's an existing unit, and I should kind of expand on that a little bit, Ilana.
Go for it. We've got time.
Usually, the utility incentives are based on the differential between a new technology and quote unquote the best in class of an existing technology. Okay. So I mean, and just take the light bulb just simple light bulb as an example. If you have a new light bulb and you want to compare it with your incandescent bulb that you've been using it for 10 years, it's not a good comparison. You have to compare it with what is in California, at least Title 24 approved, light bulb. So that's the comparison one has to do. But in processes such as this industrial process, and I think, Ali, you might have touched on a little bit on the custom incentive programs, okay? There's a lot of custom incentive programs happen where the incentives are given based on existing technology, okay? Now, based on what is, on the ground today, okay? And I should say that moving forward, if you look at in theory, looking at decarbonization and climate change, whatever we talked about, in the future, it should really be, at least in my opinion, whatever is on the ground compared to new technology, not what is, currently the standard. You know what I'm saying? So anyway, that's the comment that I want to make on that. Long answer to a short question.
It's still an improvement either way. I mean, also Michael Gary asked, while we're on the topic of the chiller, can that ammonia chiller be used for air conditioning in commercial buildings as well, or is it specifically just for industrial applications?
This particular chiller is for industrial application. Okay, but I should say that we have got. I mean, this is like this contract that we had from the Energy Commission is kind of close to $3 million. So we have yet another $3 million award from the Energy Commission itself to explore technologies, similar technologies for space conditioning, both space heating and space cooling. And guess what? Our dear friends at Maekawa are partnering with us again on that particular project. And that project has just kicked off, like a month ago or so. So it's a couple of years long project. So I'll give more answers to that in
the next ATMO, America. Well, thank you. Andy Baker then asks, I know maybe one or the other will take this. What opportunities do you see for transcritical CO2 heat pumps for space heating and cold northern climates? I don't know who maybe Ali, you can take this.
Yeah, I can certainly kick things off. I think there are great opportunities, especially depending on what a utility is considering as the baseline for that type of system. But in the CO2 transcritical systems I've worked with in New England, the heat reclaim, and slightly different structure, but the same concept, the heat reclaim potential is outstanding. And I think air to water heat pumps and larger CO2 heat pumps are going to increasingly be a larger part of the utility incentive makeup.
Can I take that?
Yeah, I was about to say, you want to add something? Yeah.
Can I take that too?
Yes, please. It's open to all of you.
For large commercial, one of our related projects, including the CEC project, is focused on large commercial buildings, and like Ali just said, it's air to water, and it's hydronic heating. But for large commercial buildings, we are looking at a super duper high lift, okay, which could be all the way, if it's a cold climate, all the way from, 0 degrees to 160 degrees. I mean, you require a super high lift in this one, because that's what the current gas systems for heating do, right? They heat the water till 160 degree F. So it's a challenge. It's a challenge, maybe cascading systems. So I don't know, again, we are researching all that stuff, so we got, a lot of people smarter than me at EPRI who are working on this.
Well, that's good to know. I mean, it's always good to have a lot of people on it. Then Ali, we've got a question about the opportunities you were mentioning, or were they just in Vermont or nationally?
So the slide I talked about different utility incentives that we've specifically seen it hasn't been limited to Vermont. It's been work that we've worked with utilities nationally. It's, I haven't worked with every utility in the country. So as much as I wanted to put up a map showing like, yes, this is a natural refrigerant friendly utility, I unfortunately can't. But the ones I mentioned, National Grid, Con Edison, Eversource, other ones out west that have custom energy efficiency programs and have that flexibility to evaluate based on energy savings through a custom calculation. Any of those, I think, provide a huge opportunity.
Great. Morgan, you were talking about 29 project applications for the 1 million budget. We got a question here, but is that enough for all the projects?
That's a great question. Yeah. So to our knowledge, we don't know of any other projects that were submitted outside of our program. So tough to say what else will come into the CARB program, but For ours, it represents 10 retailer companies, so it's 29 project applications, not all of which ended up qualifying. So it'll depend a little bit on, the scoring criteria and everything, but we're hopeful that it'll use up the budget.
Okay, it's good to know. Oh, Ammi, you're getting so many questions about this pilot project of yours. The engineers are interested. Got a question here from Irving about, are both systems using the same evaporator technology? Are they DX flooded, or what type of evaporator is being used? You guys are getting technical.
Are both using similar evaporators? Is that the question?
Yeah, are using the similar type of technology? Are they both using either DX flooded, or basically the question is what evaporators are they using, and if it's
they're using similar type of technology, I would say, is what I would say, because the 507A chiller is also manufactured by Maikawa. So this is, think of it as a one generation before. Okay. And if there are more questions, I can take that in writing and provide a response.
Yes. I think that's also a good point to note here. All of the speakers are on the platform, and you can also send direct messages to you guys. So, I'll take one more question so we can actually be an efficient session, because, 3 women in here, impressively. I think this last one's for you, Ali. It's from Richard Fenley, who asks if you're looking at routine maintenance to reduce indirect emissions, such as coil cleaning, filter replacement, and the like. He says National Grid, upstate New York, is possibly the only utility moving into that niche.
Yeah, I love that question. We absolutely are. Preventive maintenance, if you talk to almost any contractor, they'll say the best way to improve energy efficiency is preventive maintenance and cleaning your coils specifically. So that is an area in my work with Efficiency Vermont that we're evaluating as not an emerging technology, but it's emerging in how we're able to evaluate and quantify the actual energy savings. So it is a bit tricky. We've tried in a few grocery stores, and we haven't been able to quantify the energy savings, but certainly on my to-do list. And in the same vein, I mentioned we've had success with the refrigerant leak repair program, and that's another preventative maintenance measure that we have been able to quantify energy savings and the impact of refrigerant leaks on the performance of different equipment. So that's been really exciting.
Awesome. Well, thank you. I think with that, I'm going to close the session. So thank you, Morgan, Ammi, and Ali. It's been great having you, and to everyone else, enjoy the rest of your day. I hope everyone learns a lot. Thank you very much.